Hello, everyone. My name is Juan Marino, and joining me today is my colleague Akshay Patel. We're both graduate research assistants with the West Virginia University Pollution Prevention Team. Our presentation today focuses on optimizing energy use in poultry houses, which is an important step toward improving operational efficiency and reducing costs in agricultural production. Energy represents a significant portion of total expenses in these facilities, and even small improvements can have a measurable impact on performance and profitability. Throughout this session, we'll walk you through how energy is used in poultry operations, identify common inefficiencies, and highlight proven strategies and new technologies that can reduce energy consumption while maintaining bird comfort and productivity. So with that, let's get started. This presentation will begin with an overview of energy use in poultry houses to understand how energy is distributed across major systems. It will then cover common challenges and inefficiencies that contribute to higher operating costs. The session will continue with best practices and emerging technologies that can improve energy efficiency and system performance. We'll also discuss how energy accounting helps identify cost drivers and track performance. And then the presentation will close with key takeaways and a brief Q&A session if there are any questions. So poultry houses, they operate around the clock. They require precise control of temperature, ventilation, and lighting to support healthy bird growth. Because of this constant demand, energy costs can account for up to 30% of total operating expenses. Heating and ventilation themselves represent the largest portions of that energy use, followed by lighting and feeding systems. So improving efficiency in these areas is key to reducing costs and ensuring long-term sustainability. So throughout this webinar, we will look at how energy is used in these poultry houses operations, where common inefficiencies occur, and what practical solutions and technologies can help optimize performance and lower overall consumption. Heating accounts for roughly 2/3 of total energy use in poultry production, while ventilation typically represents about just 1/4. Lighting, feeding, and watering systems, together, they make up the remaining share, about 5% each. During the colder months in the winter, heating demand increases significantly to maintain proper brooding temperatures, while in warmer conditions during the summer, ventilation and cooling take the lead in total energy consumption. While by focusing improvement efforts on these two major systems, heating and ventilation, producers can achieve the greatest impact in energy savings and cost reduction. Energy use and cost fluctuate seasonally as environmental conditions change. In the winter, propane and natural gas use rise to meet heating needs, while in the summer, electricity consumption peaks as fans and cooling systems work to manage temperature and humidity. Ventilation alone can account for more than 80% of total electrical demand during the warmest months of the year. This often leads to higher peak demand charges. So recognizing these seasonal variations is essential for identifying the right efficiency measures. This can be insulation upgrades, smart ventilation controls, and radiant heating systems. This can help stabilize energy use throughout the year. Now in this section, we will look at how energy is used across different stages of poultry house operations and where the key challenges typically arise. So energy is used at every stage of poultry production. It first begins with the chick arrival, where heating and lighting are critical for brooding. Feeding and watering systems rely on electric motors and pumps. Heating and cooling maintain proper temperature as birds grow, while ventilation systems ensure air quality and control humidity. Lighting supports growth cycles, and waste management requires additional fuel or electricity for removal and disposal. it is important that to map these strategies to help identify which systems are the ones that are consuming the most amount of energy and where targeted improvements can lead to more meaningful costs. So the energy losses occur in nearly every major system within a poultry house. So heating systems often lose efficiency through air leaks and poor insulation. This wastes fuel and increase operating costs. Ventilation can also be another major source of waste when fans are oversized, when they're dirty, or when they're not properly maintained. Lighting contributes to unnecessary energy use when there are outdated or unregulated fixtures remain on that are not longer needed. Feed and water systems use motors that, if they're inefficient or, again, poorly maintained, they consume more power than necessary. And lastly, inadequate litter management can increase ammonia buildup, which in turn drives the need for more ventilation, which will bring in more costs. These inefficiencies in the poultry operations, they can compound over time. Again, heating and ventilation alone can represent nearly 90% of total energy use, meaning that even little improvements like cleaning your ventilation, your fans, can bring in significant improvements and significant impact on overall operating costs. Poultry houses face several key challenges that influence overall energy performance. The first challenge here is continuous operation. So these systems, they work 24/7, around the clock. They require constant heating, constant cooling, and ventilation. That makes even little efficiencies add up very quickly over time. Another challenge is seasonal variation. This one plays a really big role. Since energy needs shift depending on the time of the year, like I said before, heating dominates in the winter, while ventilation and cooling become more significant during the summer months. Another challenge is limited automation. This is an issue in many older poultry houses. Without modern controls, systems often run for longer or even harder than what they need. This wastes energy and increases operating costs. Another big challenge is rising energy costs. Both fuel and electricity prices have become more volatile, which puts additional pressure on producers to operate more efficiently. And finally, balancing bird comfort. This is an ongoing challenge in the poultry operations because maintaining the proper temperature and air quality really is essential for their health and their growth. But this must be done without excessive energy use. That's what makes it so challenging. Now that we have covered how and where the energy is used within poultry operations, let's take a look at some of the best practices that producers can adopt into their processes to improve their efficiency. And these are proven approaches that actually reduce waste, lower operating costs, and help maintain a proper environmental condition in the poultry houses for the birds. So first we got lighting systems, and lighting plays a really big role in both bird behavior and overall energy use. This is super simple. Upgrading to poultry rated LED systems can significantly reduce energy costs. These LEDs are designed to operate in demanding environments with dimmable and sealed fixtures that last longer and perform more efficiently than incandescent or high pressure sodium lights. Maintaining proper light levels is essential. In the brooding area, light intensity should be around 30 lux to encourage feeding and activity, while in the grow out area, around 5 lux is sufficient. Keeping the correct lighting balance here helps improve growth rates and flock health without wasting energy. But it is also important to phase out outdated lighting technologies. So make sure all their bulbs are being replaced with newer LEDs so you can cut down lighting energy use by up to around 85% and ensuring that fluorescent bulbs make sure that fluorescent bulbs are recycled properly to maintain compliance with environmental regulations. Motors are also found all over poultry houses. They power equipment such as fans, augers, pumps, among others. So because they operate continuously, their efficiency has a major impact on total energy use. So here, replacing older motors with NEMA premium efficiency motors rated at 1 horsepower or higher can significantly reduce power losses and improve reliability. These motors are designed to run cooler, waste less energy, and typically have longer lifespans. For systems that have variable demands, it's important that we add variable frequency drives or VFDs. This is the most effective upgrade that you can do to a motor. So VFDs adjust motor speed based on temperature or ventilation needs rather than just running the motor at full power at all time. So just by installing VFDs, you can reduce your motor energy consumption by up to 50%, and it will help maintain stated environmental conditions inside your poultry house. Another point here, it's also important that lubrication and alignment checks are done frequently. This will ensure that performance will be on top and it would avoid any early failure on the motor. And for smaller motors that are under 1 horsepower, replacement is usually not cost efficient. So proper maintenance becomes more important here. Another important area here is insulation and air sealing. Proper insulation and air sealing are key to maintaining stable indoor temperatures and reducing heating and cooling costs. For poultry houses, insulation targets should be around R7 for walls and R9 for ceilings. Though ideally, ceilings should reach R33 for better thermal performance. Installing an interior vapor barrier with sealed seams prevents moisture buildup and helps the insulation perform as intended. Moisture infiltration can lead to heat loss and structural damage over time. It is also recommended to use insulated brood curtains and fan covers, which typically range from R3 to R7. This would help minimize heat loss in colder months and keep conditions consistent throughout the poultry house. Finally, sill plates, fan mounts, and door frames reduces air leaks that can lead to drafts, uneven temperatures, and unnecessary ventilation loads. These little details often provide some of the highest returns on energy efficiency improvements. Then we got radiant heating systems. Radiant heating is one of the most efficient ways to maintain temperature in poultry houses, since it warms the floor and birds directly rather than just heating the air. To keep these systems running efficiently, radiant heaters should be well maintained and equipped with electronic ignition to avoid fuel waste from pilot lights. It is also important to check the thermostat calibration every 3 months, because even small calibration errors can lead to temperature swings that will be wasting energy and will also affect the bird comfort. Whenever possible, also try to avoid using forced air heating systems, unless they are zone controlled. Radiant heating provides more uniform warmth at lower overall energy costs, while forced air often results in uneven heating and higher fuel consumption. Finally, stir fans should only be added after insulation improvements have been made. This ensures that the heat produced stays inside the building and is circulated efficiently, rather than just being lost throughout leaks or poorly insulated areas of the building. Ventilation plays a big role too in maintaining air quality within the poultry house because it controls moisture and it manages temperature inside the poultry houses. So to keep the systems operating efficiently, fans should be cleaned every 1 to 3 months. Belts and shutters should be inspected regularly on a daily basis or a weekly basis. Dirt buildup and worn belts can significantly reduce airflow and increase power use. So make sure you replace those belts. Important here, when selecting fans, it is best to choose models with a high ventilation efficiency ratio, or DER. This is measured in cubic feet per minute per watt. These indicate how effectively the fan moves air for the energy it consumes. Insulated tunnel doors and inlets help minimize heat loss, especially during winter ventilation. And it also helps prevent cold air drafts from reaching the birds directly. Finally, one more point here. Producers should review and adjust summer versus winter staging cycles. Seasonal adjustments will ensure that the right number of fans run at the right time, maintaining conditions efficiently without over ventilating or wasting energy. Water management also directly impact both operational efficiency and bird health. In poultry houses, recirculating evaporative cooling water helps reduce overall water use while maintaining effective temperature control during the summer months where the weather is hotter. It is important to inspect evaporative cooling systems monthly. And if you find a leak, make sure it's fixed as soon as possible, because even small leaks can increase water and energy waste. And unmaintained pads can reduce cooling effectiveness and increase humidity in the poultry house, which we don't want. Whenever possible, producers should also convert fuel power stationary equipment like feed augers or pumps to electric systems, because electric motors tend to be more efficient. They require less maintenance and can be powered by renewable energy sources if available. And lastly, maintain a logbook for operation maintenance and tasks. This ensures that checks are done consistently and issues are identified early. Simple documentation helps track performance trends and support better decision-making for future improvements. Now, our last best practice here, implementation and funding. When implementing energy efficiency projects, it is best to prioritize measures with a payback period of less than 10 years. These typically provide the most cost-effective return while improving operational efficiency. A key first step here is to document baseline energy use. You can do this by getting an energy audit. This would include electricity consumption in kilowatt hours and propane or natural gas use in gallons. Establishing a solid baseline allows producers to track improvements accurately and quantify savings after upgrades. Producers should also take advantage of funding opportunities, such as the USDA's Rural Energy for America program, or mostly known as REAP, and the Environmental Quality Incentives program, the EQIP. These programs can cover a portion of project costs, making your upgrades more accessible and financially feasible. Finally, it is also important to keep vendor quotes and installation records, because these documents are often required for grant verification and also serve as a useful reference for future projects or maintenance. So maintaining clear documentation ensures compliance and simplifies reporting during energy audits or funding reviews. And with that, I'm going to pass it along to my colleague Akshay.
So, having discussed the best practices, now we move on to emerging technologies for energy efficiency. So, in this section, we'll look at emerging technologies that take energy efficiency a step further, using automation and smart control and data to cut cost and improve performance in poultry houses. We'll highlight key tools like smart ventilation, efficient heating, litter to energy systems, and precision feeding. These innovations are helping farmers become more sustainable, consistent, and easier to manage. So, emerging technologies are giving poultry farms new ways to lower cost while improving sustainability and overall performance. Automation in animal care helps reduce human error and keeps feeding, lighting, and ventilation consistent. It ensures that the birds get exactly what they need and when they need it. Smart ventilation systems automatically adjust airflow and temperature, which can cut power use by around 25% in some boiler farms. Efficient heating technologies like radiant brooders send heat directly when it's needed, where it's needed, to the birds, instead of wasting it in the air. And finally, litter to energy systems turn poultry waste into usable heat or electricity, reducing both energy and disposal cost. Together, these innovations make poultry houses more energy efficient, automated, and sustainable, setting the stage for technologies we'll explore next. Smart ventilation and climate control are some of the most impactful technologies for improving energy efficiency in poultry houses. These systems use IoT sensors to consistently monitor temperature, humidity, and ammonia levels. The real-time data allows for precise adjustment that helps maintain ideal living conditions for the birds. Automatic controllers take care of the adjustments. They speed up or slow down fans, open or close inlets, and control heaters, all without manual input. By doing this, farm can reduce energy use by 10 to 30%, while also improving bird comfort and air quality. It also helps avoid overventilation, which is a common source of wasted energy during colder months. On top of that, add-ons like insulated fan covers, tunnel ventilation, and steer fans can further reduce heat loss and improve uniform airflow. These systems are great examples of how technology and automation directly translates into both efficiency and animal well-being. To better understand where the biggest savings are coming from, here's a quick comparison on common heating technologies used in poultry farms. Traditional forced air systems heat the air itself, which means much of that warm air rises and escapes, especially in poor insulated houses. And they are simple but not very efficient. Radiant brooders focus right where it's needed, at the litter level. That's where the birds are, so very little energy is wasted heating unused spaces. They're ideal for brooding areas and smaller zones. Radiant tubes, on the other hand, are great for larger operations. They use infrared radiation to create consistent warmth throughout the house, reducing cold spots and fuel use. When combined with good insulation, air sealing, and smart controllers, the radiant systems can cut heating costs by up to 15 to 30% and improve flock performance. Ultimately, the goal is not upgrading one component, it's integrating heating, ventilation, and insulation for full system efficiency. Heating is one of the largest energy expenses in a poultry house and often makes up to 60 to 70% of the total energy cost. That's why improving heating efficiency offers one of the highest return on investment. Let's start with radiant brooders. These systems send heat straight to the litter level. warming the birds directly rather than heating the entire air volume. This not only keeps the flock comfortable, but reduces the fuel use up to 25% compared to the traditional forced air heaters. Radiant tubes work on similar principle but are designed for larger houses. They emit infrared heat that maintain uniform warmth across wide spaces. Then we have zone heating, which focuses on energy only where it's needed, preventing unnecessary fuel consumption in unoccupied zones. All of this work best when paired with insulation upgrades, sealed walls, insulated ceilings, and tight doors to help retain the heat you're paying for. And finally, ventilation plays a key role here too. By managing airflow, we can prevent warm air from being exhausted too quickly during colder months. Together, these technologies can make a notable difference by improving flock comfort while lowering propane or natural gas costs significantly. Litter to energy systems. Litter to energy systems are one of the most innovative technologies emerging in poultry operations. They take what's usually considered waste, a mix of bedding and manure, and turn it into a valuable energy source for heating or electricity. These systems use a combustion or gasification unit that burns the litter cleanly. The heat that is produced is then recirculated back into the poultry house. By doing this, producers can offset a significant portion of their propane and natural gas use, sometimes covering up to 40% of their heating demands. It is not just about saving fuel. This technology also helps reduce waste disposal costs and lower the farm's environmental footprint. However, it works best in a controlled environment houses, facilities that manage litter consistently in terms of moisture, bedding type, and cleaning schedule. For farms that meet these conditions, litter to energy systems can be a big step forward in both sustainability and long-term cost saving. This is a great example of how circular systems turning waste into energy can make poultry production more efficient and environmentally responsible. So, here's a simple look at how litter to energy system works. It starts with litter collection, which happens after each flock cycle. Instead of hauling it off-site, the litter is moved to a combustion or gasification unit. That heat is then captured, where it's safely burned or converted into producer gas. That heat is then captured by a heat recovery system, which redirects it into the poultry house for space heating. In some cases, the system can also produce electricity if it's connected to a small generator. The remaining ash byproduct is low in volume and can often be used as a nutrient-rich fertilizer, closing the loop on waste. Overall, these systems can reduce fuel consumption up to 40% and significantly lower disposal cost. These technologies determine how waste management and energy efficiency can go hand in hand in modern poultry production. Automation and precision feeding. Automation and precision feeding are transforming how poultry farms manage both energy and productivity. Modern electronic controllers now regulate temperature, lighting, ventilation, and feeding automatically. This not only maintains optimal growing conditions, but also minimizes the need for manual adjustment, which reduces human error and saves time. The system collects real-time data on feed conversion, bird weight, and environmental conditions. By analyzing this data, farmers can fine-tune feed delivery, ensuring each bird gets exactly what it needs without overfeeding. This leads to a major reduction in feed waste, which is one of the biggest operating costs in poultry production. Less waste also means low energy use from feed transport and storage system. Another advantage is predictive monitoring. Many systems generate automatic alerts when equipment performance drops or when there's irregular feeding pattern. That allows producers to respond before small problems turn into big inefficiencies. Overall, integrating automated systems has shown 5 to 15% savings in both energy and feed cost, while improving consistency and bird health. In short, automation is not just about efficiency. It's about giving producers better control of visibility and responsiveness across every part of the operation. So, next, we'll move into energy accounting and cost drivers. This section focuses on understanding how energy is measured, billed, and analyzed in poultry houses to identify where the best where the biggest expenses come from and where saving opportunities are located. Energy accounting gives a clear picture of how a poultry house uses energy across its various systems. Electricity costs are based not only on total kilowatt hours but also on peak demand, the highest 15-minute usage interval, which makes up nearly half of the monthly bill. When we break down electrical use, ventilation fans dominate, consuming around 70 to 90% of the electricity. Lighting typically accounts for 3 to 10%, while feeding and control systems use about 5 to 10%. On the fuel side, heating represents the largest cost driver, often between 50 to 70% of the total energy used. Efficiency in heating depends heavily on insulation, quality, air sealing, and overall house design. Energy use in poultry houses shifts significantly between seasons. During winter, heating and minimum ventilation dominates, leading to an average cost of about $5 per ton of bird produced. In summer, the focus shifts to ventilation and cooling, raising costs to around $22 per ton. This means summer folks often have 4 times higher electricity cost because of continuous fan use. Managing peak load through strategies like staggered fan operation or variable frequency drives can help reduce demand charges and stabilize overall energy expenses. To wrap this section up, energy accounting isn't just about tracking bills, it's the foundation of every efficiency plan. For most poultry farms, ventilation fans are the main drivers of electrical cost. So, improving motor efficiency and adding VFD controls can make a major difference. Peak demand management is just as important as lowering total energy use, since high short-term loads can inflate bills. When it comes to heating, savings rely heavily on good insulation and air sealing to keep warmth inside. Finally, using smart meters or data loggers help track real-time performance, verify savings, and quickly detect any unusual spikes. We have covered a lot of ground, so let's bring everything together with a quick summary and main takeaways for improving energy efficiency in poultry houses. Poultry houses run 24 into 7, and heating and ventilation alone can make up nearly 90% of the total energy use. Even small upgrades like installing NEMA motors, LED lightings, or better insulation can create meaningful savings. Emerging technologies such as IoT based control, later to energy systems, and precision feeding can help farmers boost both efficiency and sustainability. Finally, energy accounting and benchmarking remains key tools for tracking progress, managing demand, and verifying results over time. Here are some key takeaways from today's session. Start with ventilation and heating. They give the best return of efficiency improvements. Pair low-cost measures like sealing leaks and cleaning fans with targeted investment such as VFDs or smart controls. Focus on projects that pay back within 10 years and document your baseline for funding opportunities like REAP or EQIP. Keep monitoring and verifying results since efficiency is a continuous process. And finally, the goal is to move forward with more data-driven, automated management to make operations sustainable long term.
Thank you, Akshay. So we conclude our presentation. If you're interested in going a step further for an energy assessment or another type of industrial efficiency project, the WVU P2 team is here to help. You can reach out directly to Dr. Ashish Limbarte or Dr. Christopher Moore, whose contact information is shown on the slide. They manage our pollution prevention team and work closely with small to mid-sized businesses across the state of West Virginia. We provide on-site assessments, training workshops, and technical support completely for low to no cost thanks to our funding support. That wraps up the presentation. Thank you so much.